Hello everyone, my name is MD Aktaruzzaman and my ID is 12308025, a student of the Department of Computer Science and Engineering at Kumila University. Today I am going to talk about a fundamental topics in digital logic and computer design, clocked RS flip-flop and JK flip-flop. Let's begin. Table of content. Here's what I will cover today. Introduction to flip-flops, clocked RS flip-flop, working of RS flip-flop, JK flip-flop, RS versus JK comparison and conclusion. Introduction. What is flip-flop? Flip-flops are basic memory element in digital circuits. They can store one bit of data and operate based on a clock signal. They are essential in building sequential circuits like counters, memory cells, and registers. Clocked RS flip-flop. The RS flip-flop is a bistable device with inputs R and S and a clock. R stands for reset and S for set. The output sends only with the clock plus, making it a clocked RS flip-flop. Truth table. This table shows how the output behaves depending on the set and reset inputs. When both S and R are 0, the output remains unchanged. It holds the previous state. If S equal 1 and R equal 0, it means set. The output becomes 1. If S equal 0 and R equal 1, it means reset. The output becomes 0. But when S and R are both 1, it's an invalid condition. The output becomes unpredictable or undefined. This is a major limitation of the RS flip-flop. Working of clocked RS flip-flop. Here's how it works. When S equal 1 and R equal 0, output is set to 1. And S equal 0 and R equal 1, output is reset to 0. When S equal 0 and R equal 0, no sense. Previous output is held. When S equal 1 and R equal 1, this is an invalid state and should be avoided. JK flip-flop. The JK flip-flop is an enhanced version of the RS flip-flop. It solves the problem of the invalid input condition. When both J equal 1 and K equal 1, the output toggles. This makes it very useful in counters. Truth table of JK flip-flops. The JK flip-flops truth table is similar to RS at first. When J equals 0 and K equals 0, no change. When J equals 0 and K equals 1, reset the output to 0. When J equals 1 and K equals 0, set the output to 1. But when both J and K are 1, unlike RS flip-flop, this is not invalid. Instead, it toggles the output, meaning if Q was 0, it becomes 1. If it was 1, it becomes 0. This makes JK flip-flops are very useful in devices like counters and toggle switches. RS versus JK flip-flop. Let's compare the two. RS flip-flop has an invalid condition while JK does not invalid condition. JK flip-flop can toggle, but RS flip-flop cannot toggle. JK flip-flop is more versatile and widely used in practice, but RS flip-flop is limited to use. Conclusion. To conclude, flip-flops are vital in digital memory and control systems. RS flip-flop is basic but limited. JK flip-flop is more flexible and solves the invalid input issues. Mastering this helps us understand more complex systems like FSMS, counters, and registers. Thank you for your attention.